Hello students, today let us discuss some problems on the resultant force. So first let us discuss the concept of the resultant force. So let us take some examples here to make the concept clear. So this is an object. On this object, the forces are acting. Suppose one force of 20 Newton is acting towards right and the other force of 20 Newton is acting towards left. Now, keep it in mind that resultant force means I am going to add these forces but by considering the direction. That means if I take 20 Newton force acting towards right as positive, then the 20 Newton force acting towards the left will be negative. So the resultant force is 0 Newton. And hence, there is no resultant force, no unbalanced force. In this case, both the forces are balancing each other, acting on this object. Okay, and hence, by Newton's first law, if the object is stationary, it will maintain the stationary state, and if it is moving with a constant velocity, it will continue to move with the same constant velocity. Now let us consider another example here. On this object, there are two forces acting. One force of 20 Newton acting towards right and another force of 25 Newton acting towards left. So in this case, the resultant force, now keep it in mind that out of the two forces, the bigger force, I will take it as positive, then the other force that is acting in the opposite direction will be taken as negative. So the resultant force will be 25 Newton minus 20 Newton, which is 5 Newton. So in this case, the forces are unbalanced, so the resultant force of 5 Newton acts towards left. And then according to Newton's first law, if a resultant force acts on the object, then obviously the object will not maintain the state of rest or state of motion with a constant velocity. That means it will accelerate, and it will accelerate in the direction of the resultant force. That means the object accelerates towards the left. Towards the left because the resultant force is acting in the left direction. So this is the concept of resultant force. So let us take some problems on this. So example 1. In this case, we have to state the size and the direction in which the resultant force acts, and second part, here describe the motion of the object. So again, some force diagrams are given to you. So this is the first one. Now on this object, a force of 150 Newton is acting towards the right direction. Another force of 200 Newton is acting towards the left. A third force of 300 Newton is acting vertically upwards, and a fourth force of again 300 Newton is acting vertically downwards. So whenever we find out the resultant force, first of all we will find the resultant force separately in the vertical direction and in the horizontal direction. And as I already told you, if forces acting opposite to each other, say vertically up and vertically down, they are equal, then in the vertical direction the forces are balanced. So no resultant force is acting. And in horizontal direction, suppose the forces are not equal, so take the larger force as positive and the force in the opposite direction as negative. So let us see the solution of this. So first let us come in the vertical direction. So I will take Fv as the resultant force in the vertical direction, and as you can see here, the forces are equal in magnitude. That means if I take 300 Newton, say in vertically upward direction as positive, then 300 Newton in downward direction is negative. So the resultant force is 0 Newton. That means the forces are balanced. Forces are balanced. So in the vertical direction, no resultant force is acting. Now horizontal direction. Now in horizontal direction, 200 Newton that is acting towards left is larger in size. So I will take it as positive. So 150 Newton that is acting towards right is negative. So 50 Newton, and hence horizontally forces are not balanced. So a resultant force of 50 Newton, that is the size of the force, acts towards the left. So in the B part, they have told you to describe the motion of the object. That means the object accelerates towards the left. Okay, so in a particular direction, suppose the forces acting cancel out each other, then there is no resultant force acting in that direction. And if the forces are not cancelling, they are of different magnitude, then take the force which is larger as positive, then opposite force that is smaller will be taken as negative, and the object or the particle will accelerate in the direction of the resultant force. Now take the second problem here. So now in this case, a force of 600 Newton is acting vertically upwards. Another force of 700 Newton is acting vertically downwards. Then a third force of 350 Newton is acting towards right. And the force of 350 Newton is acting towards left on this particle. So let us first discuss the forces in the vertical direction. Now vertically 700 Newton that is acting downwards is larger, so I'll take it as positive. So 600 Newton that is acting upwards is negative. So the resultant force of 100 Newton is acting on the particle in downward direction. And if you consider the horizontal direction, as you can see, both forces are equal in magnitude. So I will take 350 Newton acting towards right as positive. So 350 Newton acting towards left is negative. So the resultant force is 0 Newton. That means horizontally the forces are balanced. That means a resultant force of 100 Newton acts in the downward direction. So what will you say about the motion of the particle? The particle or the object accelerates. in the downward direction. Okay, so I wish this concept is okay with you. So let us do another type of problem. So here again a force diagram is given to you. Now on this particle, a force of 3y minus 50 Newton is acting towards the right direction. Another force of 2x Newton is acting towards the left direction. A force of 4x plus 3y Newton is acting in the upward direction, and another force of 170 Newton is acting in vertically downward direction. And it is given that the particle is moving with a constant velocity, find x and y. Now, keep it in mind that it is given that the particle is moving with a constant velocity. Constant velocity means the particle is not accelerating. And since there is no acceleration, there is no resultant force acting on the particle. That means vertically as well as horizontally, the forces are balanced. So, if I consider the vertical direction, that means resultant force in the vertical direction is 0 because the forces are balanced. So total force acting vertically upward 4x plus 3y Newton is balanced by total force in the downward direction 170 Newton. So I am getting one equation here. Then consider the horizontal direction. Horizontally also the forces are balanced because no resultant force is acting, and hence the total force towards the left is equal to total force towards the right. So I get another equation, 2x minus 3y is equal to negative 50. You can just solve these equations on the calculator or just solve simultaneously. 4x plus 3y is equal to 170 and 2x minus 3y is negative 50. Now since the y coefficients are equal and opposite in sign, just add them. So 3y and negative 3y cancels. 4x plus 2x, that is 6x, and 170 minus 50, that is 120. So x is equal to 120 divided by 6, that is 20. That means x is 20 Newton. and put this x is 20 in say equation 1, so you'll get 4 into 20 plus 3y is equal to 170. So 3y is 170 minus 4 into 20, 80, which is 90. So y is 90 divided by 3, that is 30. So y is 30 Newton. So in this problem, remember that if the particle is moving with the constant velocity, or if it is given that the particle is stationary, that means the resultant force acting on the particle is 0. That means the forces are balanced horizontally as well as vertically. So I will give you some problems for practice. Now here some force diagrams are given to you. So in the first diagram, there are two forces acting towards the right. So one force, okay, I'll draw this again here, okay. So one force that is acting on the particle towards right is of 200 Newton. Other force of 100 Newton is also acting towards right. And a force of 300 Newton is acting towards the left. Similarly, there are two forces acting in vertically downward direction. So one force is of 200 Newton, other force of 100 Newton. And there is a single force that is acting in the upward direction, which is of 150 Newton. So in this case, you have to find the sides and the direction of the resultant force. And second part, describe the motion of the object. You can take one more problem here. So again, there are two forces acting towards right. One force is 500 Newton, other force is 400 Newton, and one force is acting towards the left, and that is of 700 Newton, vertically upward a force of 600 Newton is acting, and vertically downward there are two forces acting, one of 400 Newton and other of 200 Newton. Now, as I already discussed, if more than one force is acting on the particle in the same direction, add all the forces acting in the same direction and then see which one is larger, take it as positive, and the force in the opposite direction, which is smaller, take it as negative. Now, take one more problem here. Again, a force diagram is given to you. Now here on this particle, towards the right, a force of 7y minus 12 Newton is acting. Towards the left, a force of 9x Newton is acting. In the vertically upward direction. A force of 20x Newton is acting. And in the vertically downward direction, here, a force of 8y plus 64 Newton is acting, and it is given that the particle is stationary. The particle is not moving. It is stationary. So find x and y. So again, since it is given that the particle is not moving, that means it is not accelerating. So no resultant force acts on the particle, and hence the forces are balanced in vertical as well as horizontal direction. So try these problems. See you in the next class. Enjoy the day ahead. Bye students.